Okay. Seeing no questions, let's move to problem number 17. Problem number 17 says, if a geometric sequence begins with terms 1/5, 3/5, 9/5, find the value of the 12th term. I know this problem says calculator active, and in fact several problems with geometrics are calculator active. It's important, however, that you show your formula and your setup and show your work before you just plug things into the calculator. So, when I look at this problem, what do I see? I see that R, because there must be a common ratio, it tells me this is a geometric sequence. So what do I multiply to go from the first to the second term? I multiply the top by 3 and the bottom by 1. To go from the second to the third term, again, multiply the top by 3 and the bottom by 1. Another way of writing this is saying the common ratio is 3. 3 over 1 and 3 are the same thing, as you all know. So now we want to find the value of the 12th term. Because this is a geometric sequence, we know that the any term is given by this. So let's solve it out. We want A12, which is A1, which is 1/5. So A12 equals 1/5 is the same as 0.2 times 3 to the 11th power. I have no idea what this is. My calculator, however, does. So this is where you would use the calculator. Please don't just plop the answer down. Instead, show the work as to how you got the answer. Questions on number 17? Cool. The next one is number 19. So moving to number 19. On number 19 it says find the partial sum. Again, calculator active, but the work must be shown. A equals 2/3, R equals 1/3, and N equals 4. This problem might appear on the exam in the no calculator section. I'll show you how to do this without the calculator. Now, they've given me the R. Remember, R equals the common ratio. Because R is the common ratio, we have a geometric sequence. Geometric sequence, we want to find the sum, so S sub n equals A1 times 1 minus R to the n over 1 minus R. They might be wondering, what is this A here? Well, some textbooks leave out this 1 down here. So maybe next year in college or at a later date, you might not see A1 all the time, you might see A. A is just another way of writing A1. It's the same thing. So now we can apply our formula, and let's just plug in what we know. We're not adding up all the terms, we're only adding up 4 terms. So we want to find S4. Another way of saying that is the fourth partial sum. A1 is 2/3. R is 1/3 to the 4th power, all over 1 minus 1/3. Now, as I said, this problem could easily have been on the non-calculator section, so I'll work it without the calculator. And in fact, I would encourage you all to do that too. Even if you do choose to use the calculator, only do so at the very last step. So show all the work until you get up to the calculator portion. So let's walk through this. Well, S4 equals 2/3 1 minus, a very nice exponent property that you're going to want to know is that 1/3 to the 4th power is the same as this. 1 to the 4th over 3 to the 4th. Now, we can of course simplify the bottom. 1 minus 1/3, well, 1 can also be written as 3 over 3, common denominator. 3/3 minus 1/3 is 2/3. So the bottom of this fraction is really just 2/3. So let's simplify some more. S4 equals 2/3 times 1 minus 1 to the 4th power is just 1. 3 to the 4th power, 3, 9, 27, 81. All divided by 2/3. Well, now let's simplify the numerator. 1 minus 1 over 81. Again, get a common denominator. So there's the upstairs. So let's rewrite what we have. S sub 4 equals 2/3 times 80 over 81 divided by 2 over 3. Some of you all will see the answer right here and realize that these 2/3 can be canceled out. This is being multiplied, that's being divided, they cancel out, and the answer is 80 over 81. That's correct. Some of you may not see that, however. Some of you may instead prefer to keep change flip on the inside first. Let's do that. If we do keep change flip on the inside, here's what we get. Well, let's keep, let's change, and let's flip. Before multiplying, try to cancel some stuff out. The 81 and the 3 can both be divided by 3. 3 divided by 3 is 1. 81 divided by 3 is 27. The 2 and the 80 can both be divided by 2. 2 divided by 1 is 1. 80 divided by 2 is 40. So what do I have left? Well, this 2/3 hasn't gone anywhere. 40 times 1 is 40. 27 times 1 is 27. So I've got 2/3 times 40 over 27. 2 times 40 is 80. 27 times 3 is 81. The answer is the same whether you do the keep change flip or whether you cancel out right at the beginning. It doesn't matter. You get the same answer. Questions? Alright, let's do one last one. The last problem we want to do is number 21. Number 21, it says find the nth term expression and the next two terms of the sequence. This problem looks incredibly difficult, but in fact, once you break it down, it's not too bad. Right now I have these two that I've underlined in green are both raised to fractional exponents. They're the hardest part of this problem. Everything else is actually pretty doable. What might make our life easier is if we could write what I've boxed in gray as all like 2 raised to a power, just like these fractional exponents. That might make my life easier. And of course I can. 4 is the same as 2 squared. 8 is the same as 2 cubed. and 16 is the same as 2 to the 4th. Perhaps it doesn't look any easier to you, but it is actually a little bit easier. And it's easier if and only if you recall an exponent rule. The exponent rule is the following. X to the a power times x to the b power is x to the a plus b. In other words, if bases are the same and you're multiplying, then you add the exponents. It still might not be any easier, but here's where it gets a lot easier, I hope. 2 squared times 2 to the something power equals 2 to the 5 halves. This right here is the common ratio. And the question is, how did I know it was going to be 2 raised to some power? The only way I knew that was because I noticed that all of these were base 2 with exponents getting bigger and bigger. So now something must be happening here. I gotta find x. Let's do that. Here's where it's helpful to know the exponent rule. It might make everybody's life easier if you rewrite this line that I've arrowed in pink with the following. Remember, 5 over 2 is the exact same as 2.5. Now it becomes clear what x is. Because 2 to the 2 plus x needs to equal 2 to the 2.5. X must be 0.5. So if x is 0.5, the common ratio is 2 raised to the x power. So the r is 2 to the 0.5 power. To be more specific about it, 2 to the 0.5 is the same as 2 to the 1/2. And 2 to the 1/2 is the same as the square root of 2. So common ratio is the square root of 2. Hmm? 2 raised to the 0.5 and this are both the same thing. You could write it either way. So now we simply want to find three things: the nth term expression, a6, and a7. Well, a sub n is a1 times r to the n minus 1. a1 is 4. If you go back to your problem, it says a1 is 4. R is square root of 2. Raise it to the n minus 1. There's your nth term expression. Anthony, questions? But we're not done, because they want us to find the next two terms. So we need to find a6, and we need to find a7. Well, what is a5? a5 was 16 times the common ratio. What is the common ratio? Square root of 2. There's your sixth term, right there. Now, that looks a little bit different than the way they've written the terms in the past. And here's why it looks different. They wrote all their terms as bases of 2, so we can do that too. This is the same as 2 to the 4th power times 2 to the 0.5 power. Since the bases are the same,